So the place we went to was Mr. Webster's house. Now, as weird as it sounds, it was actually pretty cool. See, Mr. Webster is completely independent in energy production, which means that he creates his own energy with solar panels. In fact, he creates so much energy that the extra he sells to other houses in his neighborhood so that other people can enjoy his green energy. It's also way cheaper for him too because he makes his own electricity and doesn't have to buy it from big companies. So the place we went to was Mr. Webster's house. Now, as weird as it sounds, it was actually pretty cool. See, Mr. Webster is completely independent in energy production, which means that he creates his own energy with solar panels. In fact, he creates so much energy that the extra he sells to other houses in his neighborhood so that other people can enjoy his green energy. It's also way cheaper for him too because he makes his own electricity and doesn't have to buy it from big companies. Now, aside from being self-sufficient in energy, Mr. Webster also heats his own water. He does it like this. He has 2 solar collectors on the side of his house with pipes and an antifreeze sort of stuff running all through them. And when the sunlight hits them, the antifreeze warms up a lot, and that warmed up antifreeze travels through a pipe to a tank with cold water, and the hot antifreeze warms up the water to temperatures as high as 120 degrees Fahrenheit or 48.8 degrees Celsius. Now, on top of all the solar heating, the panels and pump are connected to a controller, which is in turn connected to a switch. The controller notices the difference between the temperature of the water in the tank and the temperature of the panels. If the temperature of the tank is higher than the panels, then it shuts off the pump that pumps antifreeze. If it's the other way around, then the pump is turned back on. The switch is only used in dire situations when the sun alone isn't enough to heat Mr. Webster's water. The switch turns on an electric boiler, which is also connected to the water tank and is powered by his solar panels. And of course, the profits. Over the past 25 years, the money Mr. Webster has saved has gone from less than $100 a year to $18,000. Now, this whole system is great because it's way better for the environment than an oil burner with all those nasty fumes, and it's free. Aside from the domestic heating system, the Webster household also gets its energy from the sun. Across the street from his house, Mr. Webster owns about 80 acres of land, on which is a large old barn. On the roof of the barn, he has 7 huge solar panels, and out in the field near his barn, there are roughly 10 17 by 22-foot tracker panels. Tracker panels are solar panels with a motor that follow the sun throughout the day. With this pattern, the tracker panels produce 30% more electricity than the dormant ones on the roof. Now, you may be wondering, how do solar panels work? Well, the inside of the panels, there are these things called solar cells. The solar cell's job is to absorb the sun's rays and convert them into DC energy, which means direct current. Direct current is where the electrons all move in one direction, all flowing through the wire, cable, or what have you in order. But wait, now there's a problem, because houses run on AC energy, or alternate current. Alternate current is where the electrons all stay in the same general area and move back and forth, picking up energy from the previous electron and giving it to the next. But how can you power a house when the energy supplier is different from the energy needed? Well, the photovoltaic arrays, or solar panels, are connected to a DC disconnect, which is sort of like an on-off switch to turn off the feed from the panels. From there, the energy goes into something called an inverter. Inverters are where the magic happens. They change the energy from DC to AC, ready to power houses. There's so much energy created that the panels on Mr. Webster's barn alone need 2 inverters. This whole setup is exactly the same for the trackers, only the trackers have individual inverters built right into them. The energy flows from the inverter to an AC breaker panel, which includes a thin wire that will break if too much energy flows through it, so the grid and the houses don't get fried.